Okay, guys, this will be our last frame, or last video. It's covering sections 5 and 6, which is recursion, and a little activation frame, which will use stacks. So section 5 is a few different recursion problems. I've actually done the solutions already here, and I'll show you those. So we want to develop a method for the first one that basically to check palindromes, and I assume the input is all the same case and is a single word. Now I haven't actually written this in Eclipse or anything, so I don't even know if the syntax is obviously right, but it should be pretty close and would be good enough for the midterm in terms of syntax for everything. So basically what we're going to do is create a method that basically checks if a thing's a palindrome. Basically, every time we go into a layer, we're just going to basically strip off the ends, check if those are equal, and then move inwards until we get down to 0 or 1 character. So if we get back down to 0 or 1 characters, we know by definition that those two are our base case, and if it happens to be the case, we can return true. Otherwise, our next thing is if the first character does not equal the last character. So that's our next check. So if the character at position 0 or the character at the length -1 aren't equal, we return false. Otherwise, we know that we're good and that we can then recursively call the next palindrome. So what I do is I call isPalindrome. There was an E missing there, but isPalindrome, and what we're going to do is pass in, we're going to use the substring method of string that basically takes the full character up to the last index spot -1. The end of that is exclusive, so we won't actually take the last location index. We'll actually take the one prior to this. So it's actually s-2, but because how substring works exclusively, we do s-1 to get rid of that first character. So then that does the stripping down of moving inward, and then from that we then keep breaking it down until we get down to our base case. So that's our first problem for recursion. Our next problem for recursion is basically writing a recursive definition for integer multiplication where we assume I is greater than 0. And what we want to do is define the multiplication in terms of integer addition. So for example, 4 times 7 is equal to 7 added to itself 4 times. So our base case here is if we can assume that I is greater than 0, so I must be at least equal to 1. What we're going to do is say if I is equal to 1, return j, which should be the number that we're adding to itself. Else, we're returning j plus, we're returning j plus the recursive multiplication of I -1, so stepping down, and then passing down j. So as soon as we get to 1, which is our base case, that returns j, so this should get called 4 times, which will then add 7 plus 7 plus 7 plus 7, which will give us 28. So that's our recursive multiply, a recursion function. And finally, our last recursive is a linear search with a recursive step that finds the last occurrence in a target. So right before I actually gave this test, I told them that this initial call was the initial call and that they were supposed to do a wrapper function that actually did everything. So what we have here is find last, and that is the main function, and we then wrap that up and call the inner wrapper, or the function that wraps up the initial call. So actually the wrapper function is the recursion method, And in this recursive method, we actually just pass in a string, the array that we're checking, and also over to our last index, which we're going to start at the end of the array. So we want to go essentially backwards in the array, and actually this is supposed to be a length minus 1 because the last index is equal to that. So that's now our recursive call that we'll make every time. So you'll notice that this method does return a string. So in our wrapper method call, we create our new definition here of our recursion. So public static string find last, and our new call is just taking in the string, taking in the array variable of strings that we're looking for, and the I. And I is originally going to be equal to the last element, array length minus 1 on the first call. So if our length or our base case is if I is equal to -1, which means we searched all the way through the array and basically we didn't find anything. In that case, we want to return null. So I know it says to return string, but null is a valid object of string, and that just means that we didn't find the string in our array. Our other base case is if the string that we're looking for is equal to the string at the location in the array I. If that's the case, we just return the location. We can return the location in the array, or S. It doesn't really matter. So here we return that string and just let them know that we found it. And then finally find last, and what we do in there is we recursively call and passing down both the target string, the array that we're looking in, and then we decrement the index by 1 until we get to 0 or -1. So we start at the back of the array and work our way down because we're looking for finding the last target of that. Versus the other way, which we could start at the first and go all the way out to the end. This way, if we start at the end and we find it sooner, we can gain a little bit of efficiency on that if we do happen to find it. And then finally, section 6. This is probably one of the easier questions on the problem. It's just kind of worded in a way that makes it seem harder. So basically, you have a choice here either to use this queue or a stack. Hopefully you remember from the lecture that activation frames were based from recursion, and every time you recall recursion, it gets added onto the stack, the programming stack of the functions and how they're activated and everything. So back in the book, if you look up activation frames, it talks, and recursion, it talks about what information is stored in each activation frame and how that's done. So with Java, we just want to create a basic activation frame class that manages them and basically provides us two methods. The first method is method called. That means we called a new method and that we need to push a new activation frame onto our stack of frames. And method returned means we finished the method and now we're returning the previous activation frame for our Java OS to repopulate the variables and do whatever else it needs to do. So simply, this is just a manager for all the activation frames and basically just handles the handling of those frames when methods go in and out based upon the call stack. So the code starts here with our public class activation frame manager. And that's our main class. The only variable that we're going to keep track of is a stack of activation frames. And here we basically just create our constructor, and all it's going to be doing is it creates a new stack of activation frames. So nothing else here. Simple constructor and creates a new stack of that. And then we implement the two methods that are required from our calls. Method called which basically takes in an activation frame and lets us know what frame information we're storing. So we just take that and push it into our stack, which we take that frame and push it onto our stack of activation frames. When we're done with the method, we get called upon to return the previous activation frame so that we can go. So method return, we're done with the method, so we need to go back to the previous activation frame. So we basically check if our if the activation frame thing is not empty. If it isn't, we just pop off the top of the stack and return. If we happen to call this when something bad happened, that's supposed to be activation frame. So here I return null in case of that we don't actually have anything to return. Hopefully we never get this method return on an empty stack of, otherwise we have a bug in our JVM. So that should never happen. The other option here is, instead of returning null, is to throw some sort of exception and let Java know that there's a serious problem with what happened and that we probably need to recode how our JVM is working because there's probably a bug. So there's checks in 5 and 6. Again, hopefully this isn't too bad, and your midterm again will be a little bit shorter than this in terms of the time and everything. So if you guys have any questions after reviewing the videos, feel free to give me an email and I'll be answering. I do have a few emails that I've gotten and I'll be answering those, and I'll be sending out these links shortly. Again, if you have any questions, please email me. Again, I do go to sleep kind of early on Sunday and try to turn off stuff after about 2 or 3, but feel free to maybe text me if you have an important question that you need answered. Anyways, good luck on your studying, and I'll see you guys on Monday. Bye-bye.